Hey guys, this is the solution to the example for problem 2 in your week 10 MyStatsLab homework. In this problem, a developer wants to know if the houses in two neighborhoods were built at the same time. So a random sample has been collected, and as we can see right here, we have our summary statistics of those two neighborhoods. So we start off with part A of our problem, and we need to know what our hypothesis is. Now, as you see in my statement here, we know that the null hypothesis is always a statement of equality or no change. And then, of course, the alternate hypothesis is what must be true if the null is false. So I have here that the mean of neighborhood 1 minus the mean of neighborhood 2 would be 0, so there is no difference between the two. And then the alternate to that will be that the mean of neighborhood 1 minus the mean of neighborhood 2 is not equal to 0, that there is a difference. So if we want to test this hypothesis, we're going to end up in part A by finding the p-value. A few steps we have to go through to get there, so let's go ahead and take a look at what we need to do. So step 1, we're going to find the pooled variance. Now this formula is in your text at the top of page 382 if you'd like to open it and take a look at it. I have solved it here in Excel. We'll take a look at it. A little bit involved, so you may want to pay attention to this. But as the formula shows on page 382, we start off with C5, which is the sample size of neighborhood 1 minus 1, so that's basically our degrees of freedom, times C7 squared. C7 is our standard deviation for our sample. We're going to square that plus F5, our sample size of neighborhood 2 minus 1, again the degrees of freedom, times F7, our standard deviation for this sample, squared. And then we're going to divide that by the degrees of freedom, C5 minus 1 plus F5 minus 1 for both of our neighborhood sample sizes. Put the formula in just like I have it here. Lots of parentheses there, so pay attention to those. And we get our pooled variance at 49.3147. Now, step 2, we need to find the standard error. Again, this formula is on the same page 382, the second formula there, and I'll click on that, and you'll see now that we have this pooled variance, we can calculate the standard error, which here is the square root of that pooled variance times the square root of 1 over C5, C5 being our sample size, plus 1 over F5, sample size of neighborhood 2. So the square root of our pooled variance times the square root of 1 over both of these sample sizes. And our calculation here, 1.7472 is our standard error. Now that we have that, we can compute the t statistic in step 3. So this formula is near the bottom of page 373, and remember that our hypothesized difference is 0, and we'll need that for this problem. I'll click on that cell, you'll see our formula there. So we're taking the difference between the sample means, C6 minus F6, minus 0, the hypothesized difference that we have here, and then we're going to divide that by D23, our standard error that we just calculated, and we get our t-stat at 2.919. Moving along, another step here, step 4, we need to know the degrees of freedom for the pooled of the two. So C5 minus 1, again 30, plus F5 minus 1, the 35 for neighborhood 2, and we get our degrees of freedom, a total of 63. Now that we have that, along with our t-stat, we can calculate our p-value. And for this, I'm going to use our t-dist formula. As you see here, it calls for D28, and D28 is our T-stat, comma, D32, our degrees of freedom, comma, 2. This is a two-sided test, so we put that in there. Click enter, and we come up with a .004 number. Now, we know from our readings that we reject the null hypothesis because the p-value is less than our alpha. Now this is done with a 95% confidence, so we know that our alpha is what's left at .005. So 0.00 is less than 0.05, and therefore we know that we will reject this null hypothesis. Okay, pretty good. Part B. In Part B, we're asked to find a 95% confidence interval using the pooled degrees of freedom. Okay, now step 1, need to find the critical T, which depends on the confidence level and the pooled degrees of freedom. We can use the chart in the back of the book, it would be on page A38, or I have a website here that we can use. We can go and it will calculate it for us. We know our degrees of freedom as we calculate it here at 63, and we also will need to know our alpha, which we also know is 0.05. So let's go to this website, take a look, and see how easy it is to use. So let's minimize our spreadsheet for a second, and here it is. Here's the website. If you copy and paste that web address I put in there for you, it'll bring you right here. It defaults to 15 degrees of freedom and not alpha of 0.5, so all we have to do is change our 15 here to 63. Click on calculate, and finally we get our value. Now this is a two-tailed test, so we know that our value is going to be 1.998. So let's take this 1.998 back to our spreadsheet. Let me do a little moving here to get our spreadsheet back up there. There we go. And there I've posted that 1.998. So that's pretty much the easiest way to do it, to keep this web address handy, and you can do that anytime to find that critical T. Now that we have that, we can go ahead and compute our confidence interval. This formula is in the middle of page 397. So first we'll do the lower limit, and you see here I have C6 minus F6, which are our two means, minus D48, D48 being the critical T value that we calculated, times D23, D23 being the standard error. Do those calculations and we come up with 1.61 for our lower limit. Same thing for the upper, only we add the D48 times D23 part to our difference there, and we come up with 8.59 as the upper limit. So we can say our 95% confidence interval using the pooled degrees of freedom is 1.61, 8.59. Well, a lot of work here, isn't it? But we're just about done. Part C asks a 95% confidence interval for the mean difference in ages of houses in two neighborhoods was 1.60, 8.60. Is the result that we calculated different from the pooled T confidence interval? We came up with 161.859 compared to their 160 and 8.60. Well, I don't know about you, but I know what I think. So you tell me, what do you think? Okay, and there you have it. That's an example for problem 2 in MyStatsLab for week 10. A lot of stuff there, a lot of information, a lot of formulas that we used in our cells. But I think you'll find that what I've done here will help you with that. Got some nice formulas. Don't forget our website here that will help you with that critical T. You can use that at any time. I like doing that. Put in a couple of numbers, which most problems we do are going to have an alpha of 0.05. So all we got to do is put in the degrees of freedom and let that calculate it for us. Very easy to do that. It gets you a lot closer. If you'll look in the back of your book at page 838, the degrees of freedom aren't continuous. Once we get up to about 30, I believe, then it starts every third, every fifth, every 10th number there. So we get close, but we can't get quite exact as we can with this website. So we can use that. So I hope this helps. A good problem, a little bit of work to do, but Excel makes it pretty easy for us. And hope you enjoyed this, and we'll see you on the next one.